Okay, let's get started. So till now we have covered so many things. So the yesterday and day before yesterday class, we discussed about what are variables, right? Just a sec. We started our discussion with what are variables, how to define a variable, what is the use of variable, why we need variable, right? And what are the types of variable. In types, we discussed about what is list, what is map, what is output variable, and what are local variables, and what is the difference between them, when to use them, right? What is the use of list and map, when to use output, when to use local, what are global variables, what are local variables here, correct? So all these things we discussed, and how to override the values at during runtime, how to override the values. There are different methods. Okay, we discussed about all these things. Now, just to recap, see what is the Terraform architecture. What happens in this Terraform architecture, sir? First, what you will do in one of the machine, you will try to install Terraform core here. You're installing Terraform core into one of the machine, and you will start writing a file, right? You whatever the infrastructure, desired infrastructure that you want, you'll start writing that this is my desired infrastructure, correct? So once the desired infrastructure is ready, we'll give this file, and this file is written in HCL language, HCL syntaxes. Once it is ready, we'll give it to Terraform core. What Terraform core will do, it will read this file first. It will read this file, and it will compare it with the existing infrastructure, correct? It will compare it with the existing infrastructure, and if there are any changes, with the existing infrastructure, it will go and create that infrastructure in particular cloud. That is what it is doing, right? So once all of these resources are or infrastructure is created, what Terraform will do, it will collect information related to this infrastructure and store under a file known as something called as Statefile, right? Under a file known as Statefile, it is storing all this information. So this is a file which contains the infrastructure about your existing infrastructure, correct? It collect all the details and store those details in this file, Terraform tf.statefile. Okay, so using this file, your Terraform is able to track what has been created from the Terraform. Okay, it is using for the tracking purpose. And when this state file gets created, whether it gets created during Terraform plan, no, it gets created during Terraform apply. Once the infrastructure is created, then it will collect all those information and keep it in a file called as state file. I hope everybody is clear with this, right? So just to clarify, see, once you do Terraform apply, first what it will do, it will create a resource. You already know, right? Once the resource has been created, once the resource got created, it stores all the information related to that resource, and it will keep it under a file known as, you already know what is that file name, terraform.tf state file. Under this file, it is storing. Okay, so what is the use of this Terraform state file? It helps us to keep track. It helps us to keep track of current available current available infrastructure. This is the advantage of using this Terraform Statefile, right? It helps us to track what is the infrastructure that is available. So this is the file used during Terraform plan and apply. So when Terraform read or decide state, it compares with the existing infrastructure. So to compare with the existing infrastructure, it uses this Terraform state file. Please be clear here. So whenever this is my new infrastructure, this is what I wanted to create. Let us assume this is my existing infrastructure. For this existing infrastructure, I have one state file. So whenever I do Terraform plan and apply, what it will do? Your Terraform here in middle, your Terraform is there. It compares your new infrastructure with the existing infrastructure. If there are any difference between your new infrastructure and existing infrastructure, then it will go ahead and create a new infrastructure and store this file. Okay, it compares with the existing infrastructure and the new infrastructure. How it is going to compare? It is going to compare using your state file. Okay, so now I hope everybody is clear with what is state file, why it is needed and everything. Now, whenever you execute Terraform plan, what happens? It just uses Terraform's state file. It just uses a Terraform state file, or it just reads the Terraform state file and it compares with the existing infrastructure. That's it. It compares with the existing infrastructure. See, it just reads and compares. But whether it is going to connect to the AWS cloud, no, it will not connect to the AWS cloud. When your Terraform will connect to AWS cloud using your Terraform, using your credentials, when you do Terraform apply. So at that time also, it uses a state file. It reads your desired state. It compares with the existing infrastructure, and then it will connect to your AWS cloud and it will create the infrastructure. In Terraform plan, what happens? Just reads the existing infrastructure, compares with it with the desired infrastructure, and it will not connect to the AWS. These are the some additional points that you need to remember. Okay, so now see, we have a file, this file, right? We have a state file. This is a very important file. Let us assume you are working in a distributed environment. What do you mean by distributed environment? See, I'm sitting in Bangalore. Somebody else is sitting in New York, and somebody else sitting in some Germany or somewhere. Now, we all are referring to the same infrastructure. We all are working for the same AWS cloud, for the same project, and we need to work on a team as a team, and we need to create the same infrastructure or maintain the same infrastructure. So for creating this infrastructure, what we are using as a team, we are using a Terraform. Okay, fine. Right? See, now what I'll do, this is me. What I'll do, I'll create an infrastructure. I'll create one EC2 machine here. Okay, EC2 machine is created. And I'm hosting one website under this EC2 machine. Okay, fine. So once the EC2 machine is created, then what happens? Your state file gets generated. You already know this, right? The state file is getting generated. But where this state file is getting generated, this is getting generated in my laptop here, in Sachin's laptop, right? Now, If this person who is sitting in London, if he wants to work on the same infrastructure, same existing infrastructure, whether it is possible for him to work on the same infrastructure? No, because it doesn't have this state file. Correct? You see, this state file existing under my laptop. He doesn't have, he wanted to work on the same infrastructure, but we don't have this state file. Only if we have the state file, we can do some modification to this existing infrastructure. Correct? Here also same thing. So whenever, if you are working in a distributed environment, that is multiple people are working together where all of us are referring to the same infrastructure. Okay, let me repeat. Whenever, if you are working in a distributed environment, that is multiple people are working together where all of us are referring to the same infrastructure, then it is not a good practice to store our state file in our local machines. I hope everybody is clear. Whenever, if you're working in a distributed environment, it is not recommended to store your state file in your local machines. So then what is the solution, sir? See, you might say, then what is the solution? First option is, you might say, we can able to upload this into a version controlling system, something like GitHub. You can upload, see, we am here, somebody else is here, somebody else is here. Now what I'll do, I'll start working at 10 a.m. I'll create some infrastructure, some state file is getting generated, I'm uploading it into GitHub. Okay, fine. And at 11 a.m. again he started working, and a new state file got, he can able to refer to, they can able to download this state file, and he can able to use the state file, and whenever the new state file is getting generated, he can again re-upload it into GitHub, right? And same, this person start working at 10 p.m. at midnight, again he can download the same state file, new updated state file from GitHub, and he can refer to the same infrastructure here. And once he's done with his work, again a new state file gets generated under his local machine, and he can able to upload that into GitHub. Okay, this is fine, it is working fine. But please tell me, I'm working here, everybody is uploading a state file into GitHub. What if this is my GitHub? What if somebody else forgot, somebody else forgets to upload the state file into this GitHub? Then what happens? See, you are not referring to the newly generated state file, you are referring to the old state file, right? So there are chances of forgetting this state file uploading. If you're manually uploading this state file into a GitHub, then somebody might forget, right? So we need a solution. So that is where we need a solution. Instead of storing a state file into our local machines, we can also store it in some location called as remote locations. Okay. Instead of storing our state file into our local machine, now we can store the same file. Where we'll store? We'll store it in remote location. First remote location as, see, now we need a solution. We can able to store this in remote location. We need to store this state file into a remote location. But there are some certain conditions. First, if I upload it into GitHub, then see, whenever what is happening, I need, before that, I'll explain this, the problem statement here. See, now what I need a solution where I wanted to maintain version of a state file. I wanted to maintain a version of a state file. Second requirement is I want an encryption. I want an encryption to my state file. And at the same time, third one we'll discuss after some time. So these are the two requirements I want to store. Okay. I want it to store in a place which support these two features. So now, if you look at the versioning, okay, so in GitHub, we have this, it is an version controlling system. You can able to store your state file here. But what is the problem? It doesn't support encryption. And what is the other problem? The other problem is the user might forgot to upload the state file into your GitHub, right? This is the problem with your GitHub. So this is not suggestible. Then what is the second option? The second option is you can store this into a S3 bucket. Okay. So what does S3 bucket do? So if you store this state file into S3 bucket, then by default, you already know it supports versioning. Correct? It is supporting the versioning. Whenever somebody uploads a new state file, automatically a backup of the state file is generated. And again, if somebody is uploaded a new state file, then again, a new state file, a version of that state file is getting generated. So in that way, it is maintaining the versions of it, right? What is the second option here? Second option is encryption. I wanted to implement a encryption mechanism to this data which are present in my state file, right? So you already know S3 bucket support encryption. What are the different kinds of encryption it supports? It supports SSE encryption and other one is KMS encryption, KMS key encryption. We already discussed about this, right? These are the two things it supports. So now the third problem statement here is, see, 1 second, why? See, now I'm storing this into a S3 bucket. Okay, fine. This is my S3 bucket. Okay. So now what I'm doing, I'm storing my state file into an S3 bucket. So if I store it in S3 bucket, what is the meaning? Then it supports versioning and then it supports encryption. Okay. Now, see, some existing infrastructure is already present here. Some existing infrastructure. So let's say one EC2 machine is already present here. I'm not getting this. Okay. EC2 machine is already present. Now, who created this? Let's say this person 1 has created. The same state file is created. A state file is uploaded into a S3 bucket. Okay, fine. Now that is at a 10 a.m. Now remaining two persons, second person and third person, they usually log in at 11 o'clock and they'll start working. Where they are working, they need to work on the same environment, same infrastructure. Now, see, here both the people are referring to people, two different peoples. Two different peoples one person and other person, two different people are referring to the same infrastructure. That means they are referring to the same state file. If you see here, if they are referring to the infrastructure, that means they are referring to the same state file, correct? So in that way, see, first person will access this state file and he'll modify some changes and he'll upload back that. Let me delete this. Oh. 1 second. See, this person will download the state file, he do some modification, and he'll upload the latest version of state file into S3 bucket. Okay, but this person doesn't know that third person is working on the existing environment and he has uploaded a new state file into S3 bucket, right? Then what he is referring to is referring to the old state file. Whatever the old state file was there is referring to that state file. If you observe here, right? So then is referring to the old infrastructure. Then that means we need a mechanism where we don't want multiple people. We don't want multiple people should work on same existing infrastructure. Okay, if there are multiple peoples, then I don't want all of them to work on the same infrastructure or same state file at the same time. At the same time, I don't want everybody to work on this infrastructure. Now, this we call it as a parallel access. Restricting the parallel access. Okay. So in order to implement that, now we are storing a state file into S3 bucket. By default, S3 bucket is supporting versioning. By default, it is supporting encryption. Now we need a mechanism. That mechanism, we call it as a locking mechanism. What is this locking mechanism? If one person is referring to the state file, this is the state file which is stored, and this is the another person. If one person is referring to this state file, then no other persons are allowed to access this state file. We are creating a lock. Only when this person is done with his work, then this lock is released. This lock is released and the other person can be able to access this state file. So that is what we are calling it as a locking mechanism. So now, instead of storing your state file into your local machine, we are trying to store our state file into a remote location, right? What is that remote location? Is a S3 bucket. In S3 bucket, why we are storing S3 bucket? We need a solution to this state file where it supports versioning, where it supports encryption, and where it supports a locking mechanism. It should restrict the parallel access to your state file. No access, only a single access to a single state file at a time. There are no multiple accesses to the state file. Right? So that is the reason why we're implementing a locking mechanism. But if you see, S3 bucket will support versioning, S3 bucket will support encryption, but by default, it doesn't support your parallel access, or it doesn't support your what is that locking mechanism. Okay, so for implementing this locking mechanism, we need to make use of something called as DynamoDB inside your AWS. You just need to create one key. That's it. And you refer the key here. Okay, it's very simple. I'll show you. Now, your S3 is supporting versioning and encryption. For implementing a locking mechanism, we are making use of another service in AWS known as DynamoDB. Okay, So these are the things that you need to remember well. It's kind of a theory part. Now we'll see the practicals. So any doubts here, sir, from anyone? Even if it is a smaller doubt, please let me know. Okay, fine. So now, see, now we'll see how to do it. First, what you need to do here is, first go to your AWS cloud. Okay. First, let us create one S3 bucket. See, I am creating a S3 bucket. Create a bucket. What I'll call S3 bucket. This, let me call it as Terraform. Tell me a name. Unique name I want, right? DevOps class 2024 Terraform. Any name, just copy this name. Just come back, come down, just leave everything, enable the versioning if you want. Just come down and create a bucket. Okay, name is not unique. Control C. Your bucket has been created now. Okay. So now what is the second thing you need to do? You need to create a DynamoDB table. Just search for DynamoDB. Open new tab. Okay. Meanwhile, I'll copy this name to here. Control V. This is the S3 bucket name. And here in DynamoDB, what you just need to do, just come to tables and create a table. Just wait, just create a table. Okay. So while creating a table, you can provide any name. I'll call it as Terraform lock or something. Okay. See, please remember while providing this partition key, the name must be lock ID. Capital L, small o, small c, small k, capital ID. Capital ID. Okay, this is mandatory. Name must be anything. Name might be anything. But this partition key you are creating here, right? That must be same as lock ID. Okay, just come down and this is it. Nothing else here. Just come to this. Let me show you one more time. Just come to DynamoDB, tables, create a table, provide any name, and partition key is lock ID. Just come down and create. That's it. Okay. Okay. Just let me delete this. Now, this is my key name, Terraform lock, right? Now, what I need to do, let me come back. See, now we have created main.tf. Second, we have created variables.tf. And yesterday I told you how to create what is the use of output.tf. Now we'll create a one more file known as backend.tf. What is this backend.tf? This is the file which is being used by the Terraform to store your state file into the remote location. I'm specifying where to store my state file. Okay, you can change this name, no worries, but standardly we'll call as a backend part. So now in backend, while writing file for the backend, what are the things that you need to keep take care? Let us see how to write this. See, it's just a small thing. First, Terraform, then you need to start with the backend. Which backend you are storing? You are storing it in S3 bucket, right? Then in which bucket you wanted to store, that bucket name you wanted to provide. See, bucket is equal to, what is the bucket name? This is my bucket name, right? Control V. Next, we need to provide, see, here we have something called as key. What is this key? Under this bucket, in which folder you wanted to store your state file. The folder name that you wanted to provide here. That's it. Nothing much. Folder name. I'll call it as backend slash 2024 slash Terraform or state file dot tf state. I'll delete this. Let's wait. Okay. So here we are providing in which bucket you wanted to store. And in under this bucket, what is the folder? I wanted to use backend as a folder. Under backend 2024 is another folder. Here I wanted to store this file. Okay. And in which region you wanted to create this bucket exists, I'll call it as US-East-1. This is the region. And the next part is you need to mention the DynamoDB table. Okay, DynamoDB table is equal to, and you just need to provide this lock ID, just the name, Terraform lock. Control V, that's it. Okay, so just close this. This is your backend part, sir. Nothing else here. Where you wanted to store, I wanted to store my backend is a S3 bucket now. Bucket name, in which folder you wanted to create, what is the region in which the S3 bucket is created, and what is the DynamoDB table locking ID. That's it. You provide, copy this, come back to your server. Where is this? Okay. So VI, let's sudo su VI backend.tf, right? Enter, insert, paste. Okay, instead of doing that, what I'll do, wait, we'll create a new, okay. Instead of doing this, we'll create a new folder and we'll create everything from scratch there. mkdir, I'll call it as state file. cd state file ls. See, nothing is here, right? First, what I'll do, I'll create a main.tf. Okay, main.tf, I think it is already there. See, okay, this is variable.tf. Where is this? We have a script, right, which is already existing. Okay, here it is. We are creating one EC2 instance, main.tf, insert, paste, wq, main.tf is ready. Then comes your vi, variable.tf. Where is my variable? This is not my variable. Where is that? This is my variable.tf. Just copy paste, right? Variable.tf is done. And even if you want, you can include output.tf, but I'm not doing it. I'll be including a new thing known as backend.tf, right? Two files already exist, vi backend.tf. Okay, just enter. Where is my script? Backend.tf, this one. Control C, come back. Okay, just save this. Now, what is the first thing? Terraform init. Encounter a problem using including a problem with the configuration described below. Okay, unexpected comma. Where in variables? Huh? If where comma is there? Okay, sorry, Terraform init. So it is whenever we will do Terraform init, what it will do? It downloads all the plugins required for Terraform to connect to the AWS. If you see here, HashiCorp AWS, it is downloading whatever the plugins required in order to connect to the your AWS. Okay. Now Terraform is init is done. Now Terraform validate. Okay. Just wait. Success. Terraform plan. Okay. Operation DynamoDB put inputs. Okay. Can anybody tell me what is the error here? If you are clearly worked on this error or clearly worked on Terraform, what is this error here? See, whenever you get an error, just don't directly copy this and keep it in Google or keep it in ChatGPT. Just try to understand this error now. What is happening here? Error acquiring the state log. Okay, fine. Error message operation error DynamoDB put item HTTP response error status code 400 request ID something. Here, if you see access denied exception, what is this access denied? If you see here, because no identity based policy allows the DynamoDB. That is, if you remember, we created one user, Terraform user at the beginning. That user has only, what are those? EC2 full access, S3 full access, but it doesn't have a DynamoDB access. If you remember, let me show you that. Here, if you search for IAM users, just come to users, and we have two users. Terraform user is the one we are using now, correct? See what are all the policies it has. Amazon full access, S3 full access, VPC full access, IAM full access. But does it have, what is that? DynamoDB access? It don't have. So that is why you're getting this error. Okay. So now you can add a new permission. Add permission, attach a policy. You already know this. Just search for DynamoDB. Amazon DynamoDB full access. Select that. Come down. Next. Add permission. Okay. Now it is added. Just come back. Clear this. Now you do Terraform plan. See, it is working now. Okay. start looking at the errors, not just don't directly go and copy paste in different formats, in different forums. Okay, try to understand that. That is how you can able to be a good uh, script writer or something like that. Okay, Terraform apply -auto -approve. Now see. See, now the infrastructure has created. LS, can you able to see? Let me show you. See, the state file is not created here. Now, where this state file is getting stored? Under your S3 bucket. If you come to, this is the one, right? Terraform backend to this one, Terraform, okay. DevOps class, this file. See, this is the folder that we created, bucket 2024. See, when it is created just now, 746, November 5, 746. Okay, now what I'll do, if you just change some configuration here, let's say vi main.f, let me change the AMI ID otherwise. Vi variable.tf. I'll change this AMI ID. Let's change this launch instance. Some Amazon Linux ID I'll take. Control C. Come back. Insert. Paste. Okay. Just save this. Again, Terraform apply. -auto -approve. See what it is doing? One to add and one to destroy. Okay, fine. No issues. Just wait. Sorry. Okay. So now you come back, search, refresh. See, where is the show versions? See, does automatically created another version of the state file. So even after 6 months or 1 year, if you wanted to refer to the same infrastructure, you just come back here, download this and use it as your state file, so that you can able to refer to the existing infrastructure at that time. Okay, this is how you can store your state file into a remote location. Fine. Any doubts here, sir? So we know other person is working on state file. See, if you are working on the state file, automatically it will not allow you to work on the state file. It will not only allow you, sir. Okay, that is the way you will come to know that okay, somebody else is working on that file. And once it is done, you can able to set a alarm for also for that alarm or a notification. But usually nobody does that. See, you can also implement a mechanism of sending out a notification once the work is once somebody else is using this state file, then a notification this person is using this state file. Once that state file is released, once that state file has not been used, then also you can send a notification, okay, this state file is not used. But nobody implements that, nobody takes care of that. Automatically everybody comes to know that. Okay, so that is the other thing. So any doubts here from anyone before we move to other thing? Okay, so this is how you store a state file into a remote location. While implementing or storing your state file into a remote location, what are the things that you need to remember? It should support versioning, it should support encryption, and it should not allow parallel access to the state file. These three things you should be implementing. For implementing this, now we are combining two things. One is S3 bucket and the other one is DynamoDB table. DynamoDB table helps you to implement the locking mechanism. Once one person access the state file, it will not allow the other person to access the same state file. It will lock that file. And S3 bucket automatically it will create the versioning and it will provide the encryption to the whatever the data which is present in that state file. Okay, so this is how you create your state file. Now we have successfully created 4 different files. One is main.tf, right? Variable.tf, output.tf, and the other one is backend.tf. Okay, so these are the different files. We'll add 2 more files to this, but as of now, these many. Okay, each and everything with a different purpose. Now, what I wanted to do you now is, see, now what I've done, I've created a S3 bucket and DynamoDB table in a manual way. First, I created S3 bucket, then I created DynamoDB, then manually did this thing, right? But now what do you want it to do? First, try by creating manually or something like that. Once you are comfortable with that, create a S3 bucket using Terraform. Create a DynamoDB lock, DynamoDB locking, whatever we created. Create that using Terraform. Okay. Once these values are created or once these resources are created, whatever the values that you want a S3 bucket name you want, right? S3 bucket name you want and DynamoDB lock ID you want, that is DynamoDB lock name you want. These two things you get it using output variable. Once the infrastructure is created, you store these two values in an output variable. And from this output variable, create a backend file. Okay. While referring, okay, what is that? Where is that file? Here, if you see this bucket name, from where it should come from this output file. Okay. I want you to do this complete automation. Create S3 bucket DynamoDB from Terraform, then get S3 bucket name and lock ID from Terraform using output variable and use this output variable values into a other block or other file known as backend.tf file. Okay, instead of doing it manually. This is what I want you to do. Just go back and try this today. Fine. So the next thing here is we have, whenever you talk about Terraform, just a second. whenever you talk about Terraform, you'll be having different blocks, right? First block is provider block. This is the block which Terraform make uses to connect to the AWS cloud. What is the cloud it is connecting, right? In which cloud it has to connect, what is the access key, what is the secret key, and what is the region it has to connect. All these details are placed under provider block. Next block is resource block. What is this resource block? And you can have only one provider block for one statefile by default. That can we change? Yes, we can change. That we'll discuss. Okay. In resource block, what you can do? Using resource block, you are going to create some infrastructure inside your AWS or any other cloud. You're going to create the infrastructure, right? Now, we have another block known as data source block. Okay. We have another block known as data source block. You must clearly know the difference between what is resource block and what is data source block. What is resource block? Resource block, it is used to create the infrastructure. It is used to create your EC2 machine. It is used to create your S3 bucket, right? Into the AWS cloud. That is what it is used to create. Please remember this word create. But what does data source block will do? See, if this is my AWS, in AWS, let's say I have some key pair which is already created. Manually, I have created some values. And while creating, now I wanted to create a EC2 instance in the same cloud. See, please understand. Now I'm just giving you an example. I have a key pair in my AWS, which is created manually. Okay. And now I wanted to create a EC2 instance using Terraform. Using Terraform, I'm creating a EC2 instance. Now, while creating the EC2 instance, I need to provide a key pair, right? See, I'm not interested in creating a new key pair. Now, what I'm interested in? I'm interested in just reading the existing key pair. I just wanted to read the data from the AWS. See, please remember, if you wanted to create the infrastructure, then you're going to use the resource block. If you just want to read, the existing infrastructure, and use them inside your Terraform script to read the existing infrastructure and use them inside your Terraform script, then you are going to use something called as data source block. Clear? So resource block, it is used to create the infrastructure. Data source block, if the infrastructure is already created in some other ways, manually already created. Now I wanted to make use of these values inside my Terraform script. So at that time, it is used to read the data, and not only reading, you can also use that data inside your Terraform script. Okay. If you wanted to do this, then you are going to use something called as data source block. Clear? Any doubts here? I hope everybody is clear with this. What is the difference between resource block and data source block? See, it's very easy. We'll see the implementation tomorrow, but I'll just show you. Whenever if you go to any of the, let's wait, Terraform AWS. See, if you go to Terraform registry here, AWS provider, HashiCorp, here you have all the resources, right? All the scripts already ready here. Let's go to EC2. See, the moment I click on this expand button, here you can able to see resource block. You just come down here. Here you have another thing known as data source block. Data source, it is just to read the data from the AWS cloud or any other cloud. Resource block, it is used to create the infrastructure. A data source block, it is used to read the infrastructure, existing infrastructure. Okay. So whenever you create or go to any of the servers, you'll be having two blocks. One is resource block and other one is data source block. Okay. It is very easy. We'll see tomorrow. Just go back and try Terraform Statefile today and we'll have a discussion on this. Okay. Now please go back and practice whatever we discussed today. I'm planning to complete by this week your entire Terraform. Okay. Major concept almost done. We have some minor concept and advanced stuff, including some real-time scenarios. Okay. That I need to cover. So please go back and revise whatever the things we discussed. Okay. So yeah, that's it for today. And we can discuss tomorrow. So thank you. See you tomorrow. Bye.